Okay, hello. This is the second part. We're going to be talking about type 2 error. Let me share my screen. Okay, now this is just kind of like before, except this time it gets a little bit more complicated. Yeah, if you have to, watch this video a couple of times and then talk to me. Really do talk to me to figure out, because it is easy fundamentally, but if you are confused, do let me know. All right, so now let's see. The first round of this video that we talked about, KIS had an average of 167, right? We say KIS has a null hypothesis is 167. And then it is true. Like, there's the math god knows the underlying truth of KIS average of height is 167. And then so now when we sample, right, when we randomly select sample size of 10, most of the time we're going to have the true average is 167. But it is possible that you pick people that are super tall, like you pick Jack, you pick DK, you pick, I don't know who else, DH, the junior. They're all really tall. So like you can actually get an average that is super tall, like for example 183, and then you're like, oh, 183 is way taller than the average, too many standard deviations away. So it's probably that KISS's true average is not 167, but that is only one of the possibilities, right? But this possibility occurs it's very unlikely, but it would happen. But so in the light, when it does happen, you think that it's wrong. So that's why this one is called an error, because that even though the true average is 167, there's a chance that you will sample in a way that will lead you to think that it's not 167. That's called this type 1 error. And remember, everything else white, that's called acceptable, because it's true. Null hypothesis is true, and then we accept it. So we accept that over here, all these white areas, that we will accept that it's 167. So that's great. So now let's take a look at this green. It's called that when null hypothesis is not true. Sorry, we need to cancel that. When null hypothesis is not true. So that means that this is wrong. So that means that we will need to find evidence that this is true. Okay, but in this scenario that you don't know that this is wrong, okay, but it's wrong, but you don't know about it. So we need to find evidence to prove that this is wrong. Okay, so how do we do that? Let's just say that in this second scenario where it's the same KIS, but the population average is not, actually, the population average is not 167. It is 172, for example. That is our KIS average, 172 over here. Okay, but we still assume that it was 167. So as you can see, this is the reality, right? This is true. But if we start selecting people that are slightly shorter at KIS, we will result in a sample that has an average, which is somewhere around here. And then remember, if it's somewhere around here, we will think that the null hypothesis is true, because take a look. Because we are still working under the assumption that it's 167, but in reality it's 172. This is the truth. This is not true. Just what we think this one is true. Okay, we need to find evidence to prove that this is wrong. So remember the original 5% critical. Oh, sorry, this is not critical. Alpha value is 5%. So this 5% actually makes us have a type 2 error. because anything to the left of this point, remember, anything to the left of this point, I'll redraw this in a second so that you will see it. Anything to the left of this point, we will keep the null hypothesis. And then everything outside of this critical value, we will reject the null hypothesis and accept that it's greater than 167. So now this is called a type 2 error. Is that this happens when we think that KIS has an average of 167 when the reality is 172. Because if we accidentally pick 10 people and then they result in an average of this height, we are going to accept that the null hypothesis is true because it's going to be like, right here. But it's wrong. I mean, we don't know that, but it's wrong. As you can see, that type 2 error, and then over here, this white part of this graph is considered correct because when KS has a height of 172, and then we select 10 people, and then we get an average over here, we're going to reject the null hypothesis, and then we're going to accept the alternative hypothesis that is greater than 167. If we put the graph together, it will look like this. So this is the regular, as you can see, 167. And then let's take a look at, this is under the assumption that the null hypothesis is true, that KIS has an average of 167. But there is a chance that we will have a wrong conclusion just because of based on luck. So over here, based on luck, we will pick certain individuals that have super height, super tall in the community of KIS, and then we will lead to a false conclusion just based on luck. And that happens 5% of the time, predetermined by this value. This is the first scenario. The second scenario is that, you go around saying that, oh, KIS probably has a height of 167, but in reality, KIS has an average height of 172. So now let's take a look. Okay, like that. Okay, this is not a good graph. Let's try it again. This is the true value. This is when the alternative hypothesis is true, 172. But just like type 1 error, there's something called a type 2 error. Because when it happens, type 2 error occurs when you do not reject the null hypothesis in this area. In this area, so if you randomly select 10 people from KIS and you pick the shortest ones, so underneath this area, you pick the shortest ones, and then you will think that, oh, because it's in this area, so that the KIS must have the average of 167. But in reality, it's 172. That's called an error because at this point, because this is true, right? We're supposed to reject this area, but we don't because we think that the null hypothesis is true. So you can see that the green is type 2 error. The red is type 1 error. Talk to me when you don't understand this. It's a lot easier than you think. Okay, just think about it. Reality, you can say certain things, right? You can say that Trump. Okay, Trump is gone probably by the time you watch this video. Let's just say that Biden enjoys 60% support on his newest law, whatever. So it's either true or not true in reality, right? So if it's true, we can test it. and then we find a certain number, it will fall between the true region. Or maybe it's not true. We don't know if it's true or not true until we have tested it. So that's why type 1 error and type 2 error, they sort of depend on each other. As you can see that when this line shifts left and right, when we increase the alpha value, the type 1 error chances decreases, but the type 2 error increases. So it's kind of like a fine balance in between the two. Because in the world, when we want to say certain things about specific numbers, so for example, election, right? Biden has a 60% chance to win the election. It's either true or not true, so that we need to look at both sides. Okay, you need to ask me questions. This unit, it doesn't appear too often on the exam, but type 1 error, type 2 error tend to be a pretty popular subject. And then this thing is called a false positive, also called a false positive. And then this region is also called the false negative. I'll try to come up with some sort of a acronym for you guys to remember, but this is the gist of it. That's it.